In this video, we're going to continue looking at properties of fluids, and in this video, we're going to look at pressure. So what is pressure? So pressure is the normal force per unit area exerted on a plane, surface, and that can be a real surface or it can be an imaginary surface. Within a fluid. So pressure is usually denoted by a lowercase p, and the dimensions of pressure are force per length squared. So that's force per area. Now, what creates pressure within a fluid? So pressure is created by the bombardment of a surface by fluid molecules. For gases, pressure varies with temperature and with density by the ideal gas law. Pressure varies with temperature and density by the ideal gas law. Now, just to review what the ideal gas law is, we have PV is equal to nRT, where P is your absolute pressure. And when I say it's the absolute pressure, that means that it's relative to an absolute zero pressure or a complete vacuum. So relative to absolute zero pressure. V with a crossbar through it is the volume of the gas. N here is the number of moles. Your capital R here is the universal gas constant. All right, so that is going to be, for example, 0.0821 liters atmosphere per mole Kelvin, or 8.314 joules per mole Kelvin. And then finally we have T, which is your absolute temperature in Kelvin. So this is in degrees Kelvin. And just to refresh your memory, degrees Kelvin is equal to degrees Celsius plus 273.15. So this is the standard expression of the ideal gas law. We can also express this in terms of density, though, and we'll do that probably more often here in fluid mechanics. So here we say N is equal to M over capital M, where this is the mass of the gas divided by the molar mass. And so plugging that in, we find P is equal to rho RT over M. So this is pressure, and for gases, it varies. Pressure varies with temperature density by the ideal gas law. The units system we're using. So in the SI system, we will use pascals, which is equivalent to newtons per meter squared. This is pascals, which is abbreviated as PA. And in the BGS system, we'll use pounds per inch squared, also known as PSI. Now, with looking at pressure, it's very important to remember if you're dealing with absolute versus gauge pressure. So I want to review those concepts. Absolute pressure is the pressure relative to a complete vacuum. So that would be the zero pressure. And we usually denote that as P sub ABS to indicate that it's an absolute pressure. Now the alternative here is to have a gauge pressure. And the gauge pressure is some pressure that's measured relative to another pressure, usually atmospheric pressure. And atmospheric pressure we usually denote as P sub ATM. And we can illustrate this difference graphically by having, for example, the pressure denoted sort of in this vertical line here, showing the pressure level increasing as we go up, so that P equals 0, or a total vacuum is at the bottom here, and we would have some constant atmospheric pressure, which we can denote here. So P atmospheric pressure, and that P atmospheric pressure is equal to 101.3 kilopascals, or 14.7 psi A, and we add the A to indicate that is an atmospheric pressure. And then relative to that atmospheric pressure, either on top of or below it, we can add a gauge pressure. So here's some gauge pressure, again measured relative to that atmospheric pressure. And again, the gauge pressure can be greater than the atmospheric pressure, or it can be less than. And so when you add those two together, you end up with the absolute pressure. So this is P absolute, and if we add the atmospheric and the gauge pressure together, we end up with the absolute pressure. So you can indicate this as P absolute is equal to P atmosphere plus P gauge. And often in fluid mechanics, we'll work in gauge pressure. We'll just assume that there's a constant atmospheric pressure, and we won't need to really take that into consideration. And so we can just work in gauge pressure. But it's easy to get these mixed up, and so you have to be very clear about what you're working with.